Ever get that feeling that the story you've been told about, well, pretty much anything, has some big chunks missing? Like you're just getting the
Yeah, like
highlights.
there's a whole other layer underneath.
Exactly. And that's what we're digging into today. We're looking at this really thought-provoking piece by Jaime Hoerricks. It's called The Long Memory of Stone.
And Hoerricks really gets right to the heart of that feeling, that sense of incompleteness, especially when you look at the standard narrative of how civilization supposedly progressed.
Right. That story usually goes something like, okay, innovation starts in the Near East, moves through the Mediterranean, and then eventually heads west, bringing the light to places along the Atlantic coast.
Sort of a one-way street model.
Yeah, a one-way street. And cultures, say in Ireland or Brittany, they often get cast as being, well, on the sidelines, kind of waiting for the main event to arrive.
But Hoerricks asks, what if that's just fundamentally wrong? Or at least incomplete? What if we need to flip that perspective entirely? Well, instead of just assuming these Atlantic cultures were, behind, what if their grasp of things like math, time, the sky, what if it was just different? Maybe even sophisticated in its own way?
That's a really intriguing question, isn't it? What if these weren't just like empty lands waiting for enlightenment? So our guide for this deep dive is Hoerricks's episode 211, The Stones Remember. And our goal really is to explore this idea of what they call relational mathematics and the knowledge systems of these stone-born people.
Okay, so let's dive into that. This challenge to the standard linear story. Hoerricks really pushes back against how that narrative doesn't just leave things out. It can actively sort of devalue what was happening on the Atlantic edge.
Yeah, it's almost like these places were pictured as just dark, waiting patiently for the knowledge bus from the east to finally show up.
Right.
But then you actually look at the landscape,
Right.
and you see these massive stone structures. I mean, these aren't just random rocks.
No, absolutely not. They're placed with incredible intention. Precision, really.
Precision is the word. Think about those passage tombs, like Newgrange. It's lined up so perfectly to catch the midwinter sunrise.
Exactly. Or you look at the standing stone circles. They're often aligned with solstices, equinoxes, even that really long, complex lunar cycle, the standstill. It takes nearly 19 years.
19 years. So they had to be watching for generations.
Precisely. And this kind of alignment, it predates so many of the civilizations we usually think of as the starting point. It shows this deep, practical understanding, not abstract formulas, but a real relationship with natural cycles that's core to this relational mathematics idea.
And it's not just vaguely pointing somewhere. Hoerricks points out how they communicate using shadow and light, the actual angles, the axes of the stones.
It's a silent language,
Yeah.
an invitation almost to pay attention, to understand, not like a decree demanding obedience.
So how did the early archaeologists, the ones who first discovered these, react?
Well, that's fascinating because many of them, trained in, Greek and Roman classics, they kind of struggled. They were looking for things they recognized, classical architecture, written text.
Yes, they didn't find them.
Nope. So often, the conclusion was, well, these must be primitive, or maybe just decorative. Some even thought they had to be built by invaders, because surely the local people couldn't manage something so complex.
Wow. That really shows how our own biases can just blind us, doesn't it?
It really does. And Hoerricks makes this crucial point. If we want to understand these sites, we have to accept that knowledge didn't just bubble up in one place and spread out. It arose all over, shaped by the local environment, by specific needs, plural development.
Which brings us to that term Hoerricks uses, stone-born people. I like that. It really captures that connection to the land, these enduring structure.
It suggests they weren't just living on the land, but were in this deep, ongoing conversation with it, recording celestial movements, seasonal shifts.
But, and this seems important, Hoerricks argues this wasn't about gaining power or wealth in the way we might think.
No, the idea is it was more about finding harmony, understanding the rhythms of their home, to live with it, not dominate it.
So back to that big question. What if these people, the ones often erased from the main story, weren't actually behind? What if they were ahead in some ways?
Or at least parallel, with a knowledge system that was relational, tied up with ritual, passed down through generations orally, through experience.
Not written down, so harder for us to see.
Exactly. And Hoerricks kind of floats the idea that maybe it's not just the passage of time that makes them hard to understand. Maybe it's also a bit of our own arrogance, a reluctance to value knowledge that doesn't look like ours.
Okay, let's dig into that more, These stone-born people and their instruments, as Hoerricks calls them, we're talking about a seafaring culture, right, along the Atlantic coast.
Yeah, think of a network stretching from, say, Cantabria in Spain up through Brittany, Ireland, Scotland, places like Islay, the Burren, connected by the sea.
So less about fixed borders, more about moving with the rhythms of the ocean and seasons.
That's the picture. And the key idea is that these stone structures weren't ruins back then. They were active tools, instruments for understanding, for remembering.
So challenging that idea of a single center of knowledge in the East. Hoerricks uses these Atlantic sites as counterexamples. Let's look at a few. Newgrange, you mentioned.
Right, Newgrange in Ireland. That alignment with the winter solstice sunrise, it's stunningly precise, and it's old. Older than the Egyptian pyramids, older than Stonehenge.
Curiously, older than the pyramids.
Yeah. We're talking about something built around 3200 BC. It marks that crucial moment, the return of the sun after the darkest point. That sophisticated astronomical observation and engineering, it speaks volumes about their practical grasp of celestial mechanics, the relational math again.
Okay, what about Callanish on the Isle of Lewis in Scotland?
Callanish is amazing. Its main alignment seems connected to the lunar standstill. That's that really subtle long cycle of the moon, takes about 18.6 years to complete.
So tracking that takes serious dedication. Decades of watching.
Exactly. It's not casual observation. It's long-term commitment, passing knowledge down. It's mathematics in motion, as Hoerricks puts it. Geometry remembered and felt over vast stretches of time.
And then Orkney, the Ness of Brodgar.
Ah, Ness of Brodgar. Relatively recent discoveries there, but finding these complex stone temples, painted walls, intricate ritual objects, and all from a time before writing was common in the area.
So it disrupts that neat timeline where writing equals sophistication.
Completely. It suggests a culture that deeply valued connection, integrating the sacred and, well, what we'd call the scientific. It wasn't one or the other.
So Hoerricks is saying these weren't just based on myths or superstitions.
No, the argument is they were based on calculation, on careful observation, agreements with the sky, learning confirmed over generations.
And done communally.
Seems that way.
Yeah.
There's not much evidence for, powerful kings directing everything. It suggests more of a community effort, focused on continuity, on slowness, on trust within the group.
Which leads to that phrase you mentioned, mathematics of belonging.
Yeah. It's math rooted in a place, held collectively by the people there. The monuments weren't just structures. They were tools for remembering, together. Less like solving an abstract equation, more like knowing how the moon pulls the tides that affect your boat trip tomorrow. It's all connected.
Okay, so let's unpack that idea of relational mathematics a bit more. Hoerricks says the stones themselves were structures of story, sky, season.
Right. They held memory, but a memory shaped by the specific environment they were in. They weren't just objects on the land, they were part of it.
And they function as invitations, you said. Invitations to relate to light, time, the earth spinning.
Exactly. It's participatory. Compare that to, say, math written down in a book, meant to be exported or displayed as a symbol of power. Hoerricks argues the stone-born math emerged from the land and sky. It was held in collective memory.
So not extractive. You couldn't just take it away easily. It required being there, paying attention, caring.
That's a huge part of it. The measurements weren't about controlling time, but about keeping pace with it, aligning with its rhythms.
Like noticing the moon rising over a particular hill, or the angle of light at a certain time of year, or when the birds come back.
Those kinds of observations. Numbers weren't separate abstract things. They were completely tied to these tangible events.
And geometry wasn't just lines on slate. It was in how you farmed, how you navigated, how you built, the rituals you performed.
Woven into daily life. And Hoerricks stresses it required more than just intellect. It required care, attention, a kind of stewardship.
Which must mean the way it was learned was different, too.
Totally different. Slow, intergenerational. That 19-year lunar cycle, you can't track that alone in one lifetime easily. It has to involve the community, passing knowledge through stories, repetition, shared observation.
So math becomes this shared inheritance, not something you own, but something you receive and pass on.
Precisely. And Hoerricks contrasts that sharply with later systems that got focused on speed, abstraction, knowledge as a commodity, something you extract for status or sale.
And the shift towards testing knowledge rather than just transmitting it within the community and measuring time by clocks instead of natural cycles.
Yeah, that marks a real break. Hoerricks feels something vital got lost there. A connection, a more holistic way of understanding our place.
So the legacy of these stone-born people, according to Hoerricks, is this reminder that math can be part of the world, binding us together.
Exactly. It doesn't have to be this separate alien thing. It can be embedded relational.
Okay, shifting gears slightly. Hoerricks talks about their own journey writing the story of math. How did this exploration feed into that?
Well, it's interesting. They mentioned starting out looking for the roots of algebra, but finding themselves pulled towards these deeper connections, the moon, lineage, inherited ways of knowing.
So it wasn't about inventing something new, but more like remembering,
Right.
recalling.
Yeah. Reassembling and recalling are the words used, tapping into older understandings that maybe got buried or forgotten.
They even mention the old Latin quadrivium, arithmetic, geometry, music, astronomy, seeing echoes there.
Right. Echoes of a time when number wasn't just quantity, but was seen as part of the structure of the cosmos, connected to harmony, to our experience of the world.
And the goal with the story of math was to tell that story without erasing these older ancestral ways of knowing.
Exactly. To make an entry point that acknowledges that people already bring intuitive understanding with them, not starting from scratch.
What kind of ancestral memory are we talking about?
Things like the rhythms you feel in cooking or weaving, the way people track seasons by the moon almost without thinking, how we process things through sound or symmetry, solve problems intuitively, recognizing those as valid forms of mathematical thinking.
So the aim is to put belonging back at the center of math education, move away from just performance and abstraction.
That seems to be the core idea, challenging the model that leaves so many feeling like, oh, I can't do math.
And this approach of writing math in full sentences, asking, what's the story here first?
Yeah, it's presented as a return to an older idea, that meaning comes first, that learning starts with connection, with relationship, both to the material and between learners.
So the story of math itself is structured around narrative, with each lesson like an invitation.
That's how it's described. Grounded in story, assuming students bring knowledge with them. It's a really different philosophical approach to teaching math.
Let's talk about that final section, they remember us still. The tone changes a bit there, doesn't it?
It really does. It feels more contemplative, maybe even a bit elegiac. Hoerricks calls it a lament, a recollection, a reckoning. It's less analytical, more about presence and acknowledging deep time.
And that title, They Remember Us Still, what's the significance?
It seems twofold, like claiming there's a memory that exists beyond written history, passed down somehow, and also maybe a hope that we can still connect to it.
There's that interesting reference to the 13th Warrior.
Yeah, the movie and book, fiction, but based on surprising historical truths about contact between Norse and Islamic cultures.
Which Hoerricks uses to highlight actual historical links.
Right. Things like trade, shared words, medical knowledge exchange, geometric instruments found in the north, Arabic script in Scandinavia, Islamic astrolabes turning up.
So it breaks down that simple East versus West idea again, shows knowledge flowed more freely.
Absolutely. And it prompts the question, if that was ignored or downplayed, what else have we missed because it didn't fit the neat imperial narratives?
And then there's the lament for the stone-born people itself. It focuses on everyday people.
Yes, not kings or heroes, boatwrights, bone setters, story keepers,
Yeah.
people connected intimately to the land and sea.
Emphasizing their way of knowing observation, listening, not conquering.
A way of being with the world, not just acting upon it, and acknowledging how later cultures built on their foundations, maybe without always realizing it.
There's that evocative image of silence that hums and remembers in the landscape.
Yeah. Hoerricks suggests writing this section felt less like inventing, more like listening, tuning into a deeper shared memory.
And the conclusion is that this memory isn't just history. It's potentially still within us.
That's the powerful closing thought, that it's there, waiting to be heard, to be remembered.
Which brings us right back to Hoerricks' final thoughts. This idea that we never start from scratch. We build on what endures. And that central nagging question.
Why do so many kids and adults believe they just can't do math? Where does that shame, that feeling of being excluded, come from?
Hoerricks' answer isn't that the math itself is too hard. It's that the connection's been lost.
Right. We've moved away from that relational understanding, that intuitive grasp.
Modern math learning often feels like climbing this ladder, right? Alone, judged at every step.
Yeah, very performance-oriented, often abstract. But Hoerricks contrasts that with older ways, like the stone-born peoples, where math was about being in right relationship with the world, the seasons, the community.
So when someone says, I'm not a math person, Hoerricks sees that as expressing a kind of wound.
A wound, yeah. A point where Something that maybe felt natural became alien, inaccessible.
And the story of math is positioned as an attempt to heal that wound through remembering.
Less a new method, more a restoration, bringing math back to being this deeply human thing tied to need, culture, story.
Built for the people who feel excluded, offering a circle of belonging, not just another ladder rung, valuing different ways of knowing.
Starting with presence, curiosity,
Yeah.
assuming that innate understanding is there, not just focusing on the symbols on the page.
So we end up back with the stones, the stars, the spoken word, the moon cycles. Hoerricks suggests that connection to understanding was never really severed, just forgotten.
That's the final provocation. Maybe the real question isn't, can students learn math? But can we teach it? Can we present it in a way that lets them remember they already knew how on some fundamental level? Makes you think, doesn't it?
Sure.
What other deep knowledge might just be waiting for us to remember?